Hello, in this video we will be talking about adding and subtracting fractions both with the same denominator or different denominators. And first we need to discuss what is a numerator versus what is a denominator. So in our first picture we see that there's a chocolate bar and there's no bites taken out of it, there's no pieces missing, and there's 20 pieces in total. So as a fraction this could be 20 out of 20, or 20 out of 20 could be represented as 1 because it's one whole. Now our pie, on the other hand, there's 8 total pieces, but 3 are being taken away. So if we were to represent the pieces being taken away, that would be 3/8. Or if you want to represent what's left, that would be 5/8. Because our fraction is representing a ratio of what is either being taken away or what is left versus the whole amount. And our colored pencils, on the other hand, there's a couple different ways depending on if you want to choose by color. If we want to choose the green ones, there's 2 green ones, the light green and the dark green colored pencil. Out of 12 total colored pencils, this would be represented as 2 out of 12 pencils. Or there's also, if you wanted to do pink, there's 1 pink out of 12 colored pencils. So it's depending on what you are measuring. So if you want to add fractions that have the same denominator, there are some rules you need to assess. Do they actually have the same denominator? If they do, you will keep that denominator and combine your numerators. Then you can solve it. You can add your numerators and simplify if that is possible. So here we have 2 fractions, 2/4 and 1/4, and we can assess that yes, they do have the same denominator. So we will keep our denominators and combine our numerators, so 2 plus 1 over 4, and we can solve that as 3 over 4. And we can't simplify 3 over 4, so your answer is just 3 over 4. Now, if we have 5/12 plus 3/12, we can assess that yes, they do have the same denominator and combine 5 plus 3 over 12. This gives us 8 over 12. And with this one, we can simplify it. We can take out a common factor of 4 from both the 8 and the 12, and this will give us 2/3. If we wanted to add negative fractions, for example, negative 11 over 6 plus 3/6, we still follow the same steps. So we do have the same denominator, which is 6. And we combine our numerators, so negative 11 plus 3 will give us negative 8 over 6. So in all of these, we keep our denominators the same. And we can reduce that, take out a factor of 2 from both the numerator and the denominator. This gives us our simplified answer of 4 over 3, but you have to keep it negative since the 8 was negative, so negative 4 over 3. Again, adding negative fractions. Now both of these are negative, so negative 2/3 plus negative 4/3. Our denominators are the same, so we add our numerators. Negative 2 plus negative 4 gives us a negative 6. And you can actually divide negative 6 by 3, which gives you a negative 2, a whole negative 2, and it's not a fraction. Or if you wanted to keep it a fraction, it could be negative 2 over a 1. If you want to add denominators that have variables in them, they're still denominators, so you don't really do anything with them. So you have 5 over a plus 3 over a. You still keep your denominator a the same, so you have 5 plus 3 over a. And this gives you 8a, and you can't simplify it since there's no other number with a. If you want to add like terms, here's an example. So you have 5/7 x plus 1/7 x. You need to factor out the x so you can combine your fractions. So you have 5 plus 1 over 7 with your x on the outside. Then you can solve your fraction, which gives you 6/7, and then you can distribute your x back onto your fraction. And you cannot simplify this. 6/7 x is already as simplified as it can be. There are rules for adding fractions with different denominators, so you need to assess, do they actually have different denominators or the same denominator? Then if they do have different denominators, you need to find the least common multiple between the two numbers, and that will give you the least common denominator, also known as the LCD. And then you'll multiply each fraction by x over x. This is just like a fancy number 1. And here's some examples like 2 over 2, 3 over 3, 4 over 4, whatever you need to do to get your common denominator. And this will give you equivalent fractions. And finally, you can add your new fractions, add your new numerators with your common denominator. So we'll do an example. Here you have two fractions, 3/4 plus 1/6. Your lowest common denominator that you can find through finding multiples would be 12. So you need to multiply 3/4 times 3 over 3. That will give you 9 over 12. And you can then find 1 over 6, multiply that by 2 over 2, which will give you 2 over 12. And now these have the same denominator, and you can add. So 9 plus 2 over 12 will give you 11 over 12, and you cannot simplify that. Just leave it as it is. Another example is 5 over 12 plus 8 over 15, and you can find your lowest common denominator, which would be 60. And then multiply 5 over 12 times 5 over 5, and that will give you your new fraction, 25 over 60. The second fraction, 8 over 15, you would multiply by 4 over 4. That way 15 times 4 gives you your common denominator of 60, and 32 for your numerator. Then you can add and simplify, so 25 plus 32 gives you 57 over 60, and you can simplify this to 19 over 20 by taking out a factor of 3 for both your numerator and denominator. Now if you have 3 fractions, you have to find a common denominator for all 3. So you have 4 over 10 plus 3 over 100 plus 7 over 1,000. Your lowest common denominator would be 1,000, because you can't simplify 7 over 1,000. Now, if you multiply by x over x, you would have to multiply your 10 by 100 and 100 by 10, but you would leave your 1,000 denominator the same. So that leaves you with 400 over 1,000 plus 30 over 1,000 plus 7 over 1,000. And then you can add and simplify. So you end up with 437 over 1,000, which you can't simplify any further than that. Now, if you want to subtract fractions with the same denominator, you have to make sure they actually have the same denominator. Then you can keep your denominator the same and combine your numerators. So like adding, now you would just subtract. You can solve your equation and simplify if you can. So if you have the example 7 over 10 minus 4 over 10, you keep your denominator, and then you have 7 minus 4 in your numerator. And this gives you 3 over 10. Which you can't simplify any further than 3 over 10. And this example is 3 over 35 minus 13 over 35, and this gives you 3 minus 13 over 35, which will give you a negative 10 over 35. And you can simplify this, taking out a factor of 5 from both your numerator and your denominator, giving you negative 2 over 7. And in this example, I want to point out that your answer is negative because 3 minus 13 gives you negative 10. If it was flip-flopped, 13 minus 3 would give you a positive 10, making it a positive 2 over 7. But things you need to watch out for is the order of your fractions. If you have denominators with variables in it, like this example, you keep your denominator the same always. So 13 over 2x minus 5 over 2x. You keep your denominator of 2x, and then your numerator changes to 13 minus 5, which you can simplify to 8. So you have 8 over 2x, and you can actually simplify this to 4 over x, because you can take out a factor of 2 from both your numerator and denominator. There are some rules for subtracting fractions that have different denominators. So again, you'll need to make sure, are they different or the same denominator? Then you'll find the least common multiple in order to find the least common denominator, also known as the LCD. and again multiply by your fancy number 1, which is like 2 over 2, 3 over 3, 4 over 4, something that will equal out to 1. Then you can subtract your new numerators with your common denominator and simplify if it is possible. So here we have the example 2/5 minus 3/8, and your lowest common denominator is 40. So you'll need to multiply by x over x, which would be 8 over 8 for your first fraction, giving you 16 over 40. And for your second fraction, it would be 5 over 5 to give you 15 over 40. Now you can solve and simplify, which would be 16 minus 15, giving you 1 over 40. Another example would be 7 over 12 minus 5 over 6. A common mistake would be just to multiply your denominators to find a lowest common denominator, but your lowest common denominator is actually 12 because 6 times 2 is 12. So 7 times 12 you don't really need to change. If you really want to show you're multiplying by x over x, you can multiply by 1 over 1. And then 5 over 6 you'd multiply by 2 over 2 to give you your common denominator of 12. So you're subtracting 7 minus 10 over 12, and this gives you a negative 3 over 12, and then this simplifies to a negative 1/4, which the proper way to write a negative fraction is to keep your negative sign in line with your fraction bar. Here's another example with 3 fractions. So like adding 3 different fractions, you need to find the common denominator for subtracting 3 fractions. So 5, 2, and 4, your lowest common denominator would be 20. And then you multiply your version of 1. So for your first fraction, it would be 4 over 4, giving you 16 over 20. For your second fraction, it would be 10 to give you 10 over 20. And for your third fraction, it would be 5 over 5 to give you 5 over 20. Then you can subtract and simplify if possible. So 16 minus 10 minus 5 gives you 1 over 20, which you can't simplify any further than that. Here's an example of subtracting like terms, kind of like adding like terms. So you have 2/3 x minus 4/9 x, and your first step is to find your lowest common denominator, which would be 9, because 3 times 3 is 9. And then you need to multiply by x over x, or your 1. So for your first fraction, you'd be multiplying by 3 over 3, giving you 6/9 x minus 4/9 x, and you can subtract and simplify. So like adding like terms, you would have to factor out your x. That way you can just focus on your fractions, giving you 6 minus 4/9, and this simplifies to 2 over 9x. And that is it for this video. Thank you for watching.